A customer sent in their controller board for an espresso machine. The issue they were experiencing is that the heating element failed, caused a power overdraw and some arcing, which did damage the controller board. Now there is some damage on the back we're going to look over under the microscope and see what we need to do in order to fix it. Taking a closer look at the controller board, we have a relay over here, and if we flip it to the back, we're going to see a little bit of damage and also some soldering attempts from the customer. Now, I don't know exactly what they did or the extent of the repair attempts they did. They did not provide that information, but it does look like we have a lot of soldering going on. We have some areas with some delamination, which I believe is from the arcing that the customer mentioned. And one thing I'm noticing, actually, if we zoom in, we have some severely cracked solder joints over here. You can clearly see a ring forming around these joints. What that means is that the component itself is not making proper contact with the PCB, and that actually can cause arcing. So I'm no longer convinced that the customer is correct, that the heating element is the cause of the arcing. It could have been a cracked solder joint on this board. Now, because the customer did tamper with this circuit board, I won't have any visual clues that would tell me whether or not the arcing occurred on the relay and it was a cracked solder joint based problem, or if it was due to the heating element as they described. All of those clues are now gone because of the tampering, which is a bit of a bummer. So if you do have an issue with one of these circuit boards, I recommend you don't try fixing it, you just send it as is. But the first thing I'm going to do, because now I'm suspicious that the relay had the arcing, I'm suspicious that this relay even works at all anymore. So my first step is we're going to remove it out of circuit and live test it and make sure it's good to go. The first thing I'm going to do here is add some new solder to all of these joints because I don't know what kind of solder was used previously. And I'm going to add some of my leaded solder, which I know flows quite well. Also, my leaded solder does have flux in it, which will help with the flow. All right, now that we're able to get good flow, we're going to go ahead and desolder all of that solder. Okay, it looks like we have just a little bit of solder left in some of these joints, so we're going to finish that off with our desolder wick. Let's see, can we wiggle the relay out? We're getting some movement. It seems like it's kind of stuck to the board, however. There we go. So the front side does not look like there's any damage to the PCB, which is good news. And our relay looks a little bit melted, so it's possible that the customer may have damaged it with their soldering iron. I really wonder what happened here. Okay, we're going to show you how a good relay is supposed to work, and we're going to compare that to the relay that we just took out of circuits. So I'm attaching a positive and negative probe over here, and that's going to inject 12 volts into our relay from our DC power supply. And so actually, so this relay is rated for 12, but I'm only going to actually inject 9 volts. And I have my meter set to continuity mode, which means when I get a short between my leads, we get a beep. And these two pins are supposed to be shorted, these two pins are supposed to be shorted, and these two pins are supposed to be shorted together. Now we'll notice that these two pins are shorted to one another, which means these are as well. However, these two over here and over here are not. When we turn on our DC power supply and inject 9 volts, now these two pins are no longer shorted, so neither are these, but these over here now are shorted, and same with these two. So that does confirm that this relay, which is a known good relay, is good. Let's compare it to our customer's relay. So these two are shorted to one another, that's good. These are also shorted to one another, that's also good. And same with this one, okay. Let's go ahead and hook in our DC power supply, and let's check. Are these two shorted to one another? They are. Same with these two. Let's turn on our power supply. We just got to click. And I'm not getting a short. And I am not getting a short. And we are supposed to. Try again. No short. no shorts. So because I'm not able to get a short over here when the relay is supposed to be activated, that tells me that this relay is defective and it's not properly engaging, so we will need to replace it. All right, so now that we have our replacement in, let's go ahead and solder it down. All right, we're gonna go ahead and give this whole mess a little bit of a clean with some isopropyl alcohol and a Q-tip. I'm just trying to get the bulk of the flux off at this time. We'll go ahead and get rid of the fibers in a minute. Okay, that is looking a heck of a lot better than what we had before. However, an issue still remains, and that is the cracked solder joints on these guys over here. Now this one is a no connect, so we're not really worried about it, but this one I am a little more concerned about. I'm gonna do a quick little inspection. This one is looking a little bit suspicious, so we're gonna reflow that as well. Looking okay over here. This guy could be beginning to crack on this side, so we'll go ahead and reflow that. Okay, and the rest is actually looking pretty good. I'm not seeing anything that is too suspicious. This looks to be like the beginning of some corrosion, so we'll just clean that off. But that's okay. So the only other thing I'm gonna look at is these three relays. We're gonna go ahead and take a look to see if those have cracked solder joints. And that's gonna be these pins over here, which they look fine, and then these large pins over here, which also look fine. So I think that aside from these two over here and a couple of the other suspicious ones, we should be good to go. We're gonna go ahead and give the entire board a quick clean, and that should be it. Okay, this does complete our repair for this controller board. If you have an espresso machine or a similar type board with some damage that you'd like for us to repair, we'll have our contact information in the description down below. Otherwise, if you found the video helpful or useful, make sure to leave us a like, subscribe for more content, and thank you for watching.